This is math lecture tutorials, and today we are going to be looking at matrices. And alright, so don't forget to like, subscribe, and also share this video. Okay. Alright, so what is matrix? Matrix is a rectangular array of numbers, symbols, or expressions in row and column. So it is not only numbers that form a matrix. Your element in your matrix might not only be numbers, it might not only be maybe letters, it can be expression, it can be symbols, it can be anything. But matrix is just a rectangular arrangement of numbers, maybe symbols or expressions in what rows and column. So when you have an expression or a symbol having being arranged in rows and columns like this, then we say it's a matrix. I get it now. All right, let's look at examples of matrix now. So we have examples of matrix. We have for matrix A, we have this is an example of matrix, and the matrix A is a 2 by 2 matrix. Now, these are the column. I get it now. This is column 1, this is column 2. I get it now. So if you this is that's those are the columns. So if you ask to identify the columns here, this is column 1 and this is column 2, and also this is row 1 and this is row 2. I get it now. So and this is also a 2 by 2 matrix. Why? Because this 2 by 2 means this 2 is for row and this other 2 is for column. I get it now. So if I say what type of matrix is this, you already know is what a 2 by 2 matrix. Reason being that what we have what 2 rows, row 1 and row 2, and we also have 2 columns, which is column 1 and column 2. Then we see that is what a 2 by 2 matrix. I get it now. Alright, so we also have this, we are under examples of matrix, so we are looking at some examples of matrix here. So we also have a 3 by 3 matrix. So the matrix B here is a 3 by 3 matrix. Why? Because you have 3 rows and 3 columns. This is row 1, row 2, row 3, 3 rows. We also have 3 columns, this is 1, 2, 3, which is 3 columns. So it becomes a 3 by 3 matrix. I get it now. So that's that. Let's look at matrix C. Matrix C now, it is a 3 by 1 matrix, because reason being that what we have 3 rows and 1 column. I get it now. This first number stands for what? Row. R. This other number stands for what? Column. The column number. I get it now. And if you want to write 3 by 1 matrix, you usually written like this, where you have a kind of times at the middle. I get it now. Alright, so this is a 3 by 3 matrix because you have 3 rows. This is row 1, row 2, and this is row 3, and just 1 column. So it becomes what? Matrix C is what? A 3 by 1 matrix. So these are some of the examples of matrices we have. Now let's look at matrix D. Matrix D now is called an n by m matrix. Reason behind what? We have m number of rows. That is, look at it now. This is row 1, row 2, again row 3, row 4. We can have row 5, row 6, row 7, row 8, till we get to what? Row n. I get it now. Row 1, row 2, till we get to row n. So we have n number of rows, and if you look at the column, this is column 1, this is column 2, guys. Now column 1, 1, 1, column 2, 2, 2, column 3, 3, 3, 4, 4, 4, till we get to a column what? A column m. I get it now. So this is having m. This means it continues. I get it now. It continues. So we have m number of columns and n number of rows. So we have n number of rows and m number of columns. So this becomes a what? A n by m matrix. So this is a general what? Matrix, which is what? A n by m matrix. Where your n stand for what? Number of rows, and your m stands for number of column. Is it clear? So these are some examples of matrices that we have. I get it now. Alright, so we also have types of matrices here. So we have some types of matrices, which we have a lot of different types of matrices. So I just list some that I feel are important and are also necessary for your understanding. Are we together? All right. So you have types of metrics. You have number one here. You have zero metrics. It can also be called null metrics. I get it now. So this is a zero matrix. A zero matrix. This is a type of matrix whose entry are all zero. So when you have a matrix whereby everything is zero, irrespective of the number of rows or number of column. So far, all the elements they are all zero. Then becomes what? A zero matrix. I get it now. So that is that about that. We also have a square matrix. Now for a square matrix is a matrix that has the same number of column and same number of rows. That is, if the column is 2 column, we also have 2 rows. If the column is 3, the row will be 3. If the column is 4, the rows will be 4. I guess now that is why you have a 2 by 2 matrix, we have 3 by 3 matrix, we have 4 by 4 matrix, we have 5 by 5 matrix, we have 6 by 6 matrix. Name it, a lot of different kind of matrix. But for your level, we are only stopping at 3 by 3 matches. So maybe when you go further and further, you deal with 4 by 4 matches and many other different forms of matrix. So matrix is a very wide and broad kind of topic, but it is constrained to 3 by 3 for your own level at this point or for this video. Are you getting it now? Alright, so let's look at identity matrix. So you look at it, you have A here, you have 2 rows and 2 columns, so it's a 2 by 2 matrix. You have 3 rows, 3 rows, row 1, row 2, row 3, and 3 columns, column 1, column 2. These 3 rows 1 2 3 and 3 column 1 2 3 becomes a 3 by 3 matrix. I get now. This is 2 column and 3 and 2 rows, so it becomes a 2 by 2 matrix. I get it now. Now identity matrix, which is denoted by I, is a matrix whose this is a matrix whose diagonal elements are 1 and every other element are 0. That is, the diagonal is 1. This is a very important and significant type of matrix because it's going to be useful in different calculations that we'll be doing, different kind of maybe when you are exploring the options about matrix, you are learning a lot of things about matrices. You see that identity matrix is a very important matrix when you are dealing with the topic matrix and every topic that relates to matrix. You get it now. So that is why identity matrix is a very important matrix. So we have a lot of things under identity matrix. Alright, so yeah, we have this. If you look at it, this is a 2 by 2 identity matrix. We have a 2 by 2 identity matrix here, which is, you see that this is column 1, column 2. We have row 1, row 2 also, and the diagonal is just it's just one entry. So diagonal is 1 and every other element is 0. I get it now. So it becomes a 2 by 2 matrix. Here too we have a 3 by 3 matrix. You see that the diagonal is 1 and every other entry is 0. That's why it's called identity. If one entry is maybe 2 or 1 here or anything here, it is no longer an identity matrix, but it becomes just a normal matrix, just a square matrix. I did now. So for a square matrix to be called an identity matrix, the diagonal should be 1 and every other entry should be 0. So the diagonal should be 1 and every other entry should be 0. So it becomes an identity matrix. So this is a 2 by 2 identity matrix, this is a 3 by 3 identity matrix. Is it clear? I get it now. Alright, so now let's move to the next kind of matrix that we have here. We have transpose of a matrix. This is not really a kind of matrix, but it's just a kind of solving of matrix. So for transpose of a matrix A denoted as A transpose is the process, or the transpose of the matrix A denoted as A transpose is the process by which the rows of the matrix A becomes the column and the column becomes the row. That's when we say a matrix A is equal, or a matrix, or this is how we define transpose of a matrix. So transpose of a matrix is usually denoted with A raised to power t. So anytime you see A raised to power 3, you already know that it is talking about transpose of a matrix. I get it now. Alright, so how do we deal with transpose matrix? This is a matrix A. So if I want to find the transpose, what is transpose means? It says that the row can become column and the column will become row. This is column 1. So the column can become row here. Why? By switching it like this. Can you see it now? So that is this column, I will change it to row like this, as if you want to turn it. This second one too, I'll change it to to row like this. I get it now. So that means that you look at 1 and 4. So 1 and 4 comes this way, becomes 1 and 4. Can you see now? And the other one to come this way becomes what 3 and 5. So it becomes what A transpose. Is it clear now? All right. So we also have symmetric matrix. So for symmetric matrix, a matrix A is said to be symmetric if A is equal to A transpose. So if A is equal to A transpose, then you say that the matrix is symmetric. So this is also another. This is C. Sorry. So this is a symmetric matrix. When you have a matrix A is said to be symmetric if A is equal to A transpose. That is, now this is your A. If I find the A transpose and they are equal, then we say that that matrix is what? A symmetric matrix. Now looking at this now. Alright, so looking at this now, look at A. A is this. So for each transpose, if I find the A transpose, that is row become column and column become row. If you look at it, come this way, and this other one to come this way. That is, if I bring this one here, it becomes 1 and 2, still 1 and 2. I bring this one down, still 2 and 1. You see that they are equal. Then if you have a matrix whereby what they are equal in this such manner, then we say that what that matrix is what a symmetric matrix. Is it clear? Alright, we also have what we call a skew symmetric matrix. A skew symmetric matrix. Now, a matrix A is said to be skew symmetric if A transpose equals to minus A, or A is equals to minus A transpose. That is, when you have a matrix A, if I find the transpose, it will be the negative of what A. I get it now. So let's say you have A to be this. If I find the transpose, know the transpose to come this way. The second one to come to the middle like this. I get it now. And the third one to go down this way. I get it now. So find the transpose. So for this one, now it come this way. You have what 1 0 minus 2 and 3. Can you see now? And for this second one, if we come this way, it becomes 2 0 and minus 1. Abi, you have 2. Sorry, it becomes 2 0 and minus 1. This is it here. And for the third one, this one comes down this way and becomes minus 3 1 and 0 minus 3 1 and 0. Can you see now? So that's A transpose. Now if you compare A and A transpose, you see that what is just like negative of this one is this A transpose. Look at it, you have 0 0. This is minus 2 and this is 2. This is 3, this is minus 3, this is 2 and this is minus 2, this is 0, this is minus 1 and this one is 1. Can you see now? This is minus 3 and this is what 3. This is 1, this is minus 1, 0 and 0. Can you see now that A is equal to A transpose? So that is why we call it what a symmetric matrix. Is it clear? So that is that about that. Now we have other matrix which you can also explore on your own. We have orthogonal matrix. We have different kind of matrix, many different kind of matrix that you can explore on your own. I get it now. We have a symmetric, which you have also mentioned. You have singular matrix. You have non-singular matrix. You have a lot of kind of matrix which you can explore on your own. I get it down. But for this video or for this course, we are only limiting ourselves to just these 6. Is it clear now? So this will be the end of the first video, which is we're going to be talking about just matrix, introduction to matrix, which we have already explored the options of definitions and the examples, how we understand or how we can see that the matrix is 2 by 2, 3 by 3, or how we can discern or know the rows and column, number of rows and column in the matrix. And also we have also explored different type of matrix, and with this you should be able to understand of or have a good understanding about what matrix entails and the little nitty-gritty introduction to matrix. So in our next video we are going to be looking at maybe addition of matrix and different operations that you can perform in the matrix, subtraction and the likes, and how to go about them basically now. So this is all for now, so I'll see you in the next video.